Now let us see why hypothesis testing is important in data analytics. In data analytics, usually we work with big data, a very large amount of data, and working with all the data is not possible for any analysis. So for analysis, we take a sample of data and use it for our experimentation. But the question is how to ensure that this sample represents the population. How to infer the analysis done on the sample is equally applicable to the population. Yes, these questions can be answered through what is called hypothesis testing. Here, the data available, which we call a population. From the population, a sample is taken, and on the sample, experiment is done, and the results of experiment done on the sample are used to infer for the whole population. That's the idea of hypothesis testing. So when you're working with the data space and sample space, the data space also called the population space. So in this the portion of the data in population space is represented by P, whereas in the sample space or statistic space it is represented by P hat. The mean of the population is mu, whereas the mean of the sample is x bar. Standard deviation of the population is represented by sigma, whereas the standard deviation of the sample space is represented by S. And we want these parameters to be equal. So to ensure that whatever experiments are done on the sample space should exactly reflect the whole population. So we would want to see whether mu equals to x bar, whether sigma equals S, and so on. So that's the aim of our sampling and experimentation. That is the statistical activity we do. So the hypothesis testing in data analytics or machine learning. In the first step, we read the data, understand and prepare the data. The second step, we build the machine learning model and then formulate and test the hypothesis, and based on the test outcome we refine the model. So here we build a model that works for our population, but the model building is not done on the population, it is done on the sample. Therefore we want to make sure that the model built for the sample is applicable to the whole population. So that's one idea we have, and that's one thing we need to ensure while working with the samples. So the key steps to perform the test is first thing is formulate a hypothesis, then determine the significance level, then determine the type of test we would like to perform, then calculate the test statistic values and the p values, and finally make the decision. So as discussed earlier, a hypothesis, we have two things, one null hypothesis and one alternative hypothesis. So first formulate the hypothesis, that what is null hypothesis and what is the alternative one, and then define what is the significance level alpha that can be used for our experimentation. It can be varied as per the level of accuracy expected from the experiment. So a better significance level means smaller the significance level, the better accurate inference we can get for. Then determine the type of test. There are many types of tests available. So in our coming sessions, we look almost 17 types of tests used in our regular machine learning activities, though there are many defined under the statistics world, but around 17 are mostly useful in machine learning world, and they are formulated under 5 categories. So we just look them in detail in the coming sessions. Then once the type of the test is decided, depending on what is problem at hand, then calculate the statistic values and then p-value. And if p-value is greater than significance level, then we cannot reject the null hypothesis. If the significance level or if the p-value is less than or equal to significance level, yes, we can reject the null hypothesis, so we can make the decision. So yes, we are working in probabilistic world, therefore nothing can be said perfectly, so there are possibility of errors. So there are 4 possibilities in all. So one is the reality and one what happened. The reality may be the null hypothesis is true or the null hypothesis is false. And our experiment will get us the p-value such that we may reject the null hypothesis or we may fail to reject the null hypothesis. So the rows talk about the outcome of our experiment and the columns talk about the reality. So the reality was the null hypothesis is true, but it was rejected, then we have an error. This type of error is type 1 error. And we reject the null hypothesis when null hypothesis was false. Yes, that was a correct decision taken. Then we fail to reject the null hypothesis when null hypothesis is true. Yes, that's also a correct decision. But null hypothesis was false, but we could not reject it. Yes, that's an error. This is a type 2 error. So the overall thing is we need to look at how many type 1 errors are there, how many type 2 errors are there, and what is the component of type 1 error, what is how much is the type 2 error, and depending on this for various test types we can see how type 1 type 2 errors are varying and then decide the appropriate hypothesis testing method that can provide the best result, that means with the minimum possible type 1 error, minimum possible type 2 error, or in all, minimum possible error. So that's what we are looking. So we would like to continue our sessions into the various types of hypothesis test possible, which are useful for machine learning data analytics. Keep watching. Thank you.